Okay, a couple things I want you to notice when it says evaluate the determinant. Normally, when you have a matrix, it's in that form, A, B, C, D. When it looks like absolute value bars, that's the command evaluate the determinant. So anytime you see what looks like a matrix and it has what looks like absolute value bars, that's telling you, oh, we need to find the determinant. And this is the process. It's the A times the D value, subtract the B times the C value. So in this case, here's our A, here's our B, here's our C, here's our D. So our A value times our D value, subtract our B value times our C value. So let's see, what do we have? 1 times negative 2 is negative 2. Subtract negative 2 times negative 5 is positive 10. So in this case, our determinant is negative 12. And then we're going to use this determinant. We're going to use the reciprocal. So it'd be negative 1 over 12 when we find the inverse. By the way, to find a determinant, it can only be a square matrix. So if you had a 3 by 2, you wouldn't be able to find the determinant. So what I mean by square, 2 rows, 2 columns, 3 rows by 3 columns. So determinant can only be used on a square matrix. Okay, let's do another one. So the determinant is our A value times our D value, A, B, C, D, subtract our B value times our C value. So we have negative 20, subtract, I didn't mean to write B, subtract negative 16, so that becomes add 16. So we have negative 20 plus 16 is negative 4. Now, we use this information because when we go to find the inverse, notice we're back to matrix form. We're going to find the determinant. So our D equals negative 1 times negative 4, which is 4, subtract our B value times the C value. So that's subtract negative 15. So subtract a negative, our D is equal to 19. 4 plus 15 is 19. Okay, so that's step 1. We're going to rewrite the inverse matrix. Pay very close attention. The inverse matrix starts like this. Notice the D and the A swap places. So negative 4 is going to come here. Negative 1 is going to come here. And then the original B and the original C, they're just going to be multiplied by negative 1. So when we multiply negative 5 by negative 1, we get positive 5, or negative 1 times negative 5. And then we've got negative 1 times 3. All right, so now we have the inverse matrix. And then we're going to multiply the inverse matrix by the reciprocal of the determinant. So the determinant was 19. So 1 over 19, so 1 over D. And then sometimes, so the determinant is just the scalar. Like before when we were doing scalar multiplication, so the determinant is a form of a scalar, and then you would multiply. So if we did the distributive, that would be negative 4/19, positive 5/19, negative 3/19, negative 1/19. So this would be the completed inverse matrix. This is sometimes the form, because sometimes your teacher is going to want to see what discriminant or determinant you found. And I think here, we'll do one more of those. So we're first going to find the determinant. So 3 times 3, subtract negative 8 times negative 8. So 9 subtract 64 looks like negative 55. So we know we're going to multiply 1 over. So that's negative 1/55. And now we're going to swap these two. Well, isn't that interesting? When we swap them, they actually stay the same. And we're going to multiply each of those by negative 1. So the final becomes negative 3/55, 8/55, 8/55, negative, I'm sorry, these are all negative. All of those stayed the same like that. All right. But oftentimes, the teacher's going to want to see this. They may not want you to do the final multiplication. All right. That's it for the videos, week 17.